Let's talk about queues, right? Gaze at this side. The first lady can leave first, right? But the last one should wait for a long time, right? We call rear where we add a value to the queue. See, this is the rear of the queue, right? You can add only value to the back of the queue, right? You can add only value to the back, right? You can't add value from the front. You can't add anything from here, right? Simply remember, insert the value from the rear, insert, and delete the value from the front end, right? Another name for a queue is a FIFO, or first in, first out, right? It allows a sequence of items to be processed on a first come, first served basis, right? In most computer installations, for example, one printer is connected to several machines, right? So that more than one user can submit printing jobs to the same printer, it maintains a queue, right? We use a queue in operating systems, right? In operating system, queue of print jobs to send to the printer, queue of programs or processes to be run, queue of network data packets to send, right? In programming, we use the queue in programming, right? In programming, a queue is modeling a line of customers or clients, storing a queue of computations to be performed in order, right? What are the real world examples? People on an escalator or waiting in a line is a queue, right? And cars at a gas station or on an assembly line, right? It is a queue, right? This is the three-state transition diagram in operating system, right? First one is resident queue. It is waiting for memory on a disk, right? Second one is ready queue. In memory has everything it needs to run except the CPU, right? Third one is suspend queue. It is waiting for input and output transfer or to be resigned the CPU, right? The next one is queue's abstract data type. A queue is a data structure that works on the rule FIFO, right? Just like a line at a bus stop, right? A queue is a special type of list where items are added at the back, rear. Items are removed from the front, added at the back. Back means rear, right? Okay. Only the front element can be accessed, right? Okay. Elements are stored in the order they are inserted, right? If you insert value, this is the order, right? Okay. You insert only at the back. You remove only from the front. You cannot access middle elements, right? You should access first the front element, right? Inserting is called enqueue. Deleting is called as dequeue, right? These are the main operations on a queue. First one is traversing. What is the traversing? Print all the array elements one by one, right? Insertion. adds an element at the given index. Deletion, deletes an element at the given index, right? Search, searches an element using the given index or by the value, right? Update, updates an element at the given index. Display, display the contents of the array, right? This is an element, okay? See this diagram. You can't add any value for this, right? This is the max key, right? Okay. We have to insert 3, 5, 8 and 7, right? At this time, front and rear are equal to -1. It means queue is empty right now, right? If the queue is empty, then front and rear are added by 1, right? It means now you can add 3, right? Like this, right? Front and rear is 0 at this time, okay? Then add 1 to the rear and insert the next value. Front and rear is equal to 0, but we should add 1 to the rear. Therefore, rear should be 1, right? Okay. In this time, rear is this, right? I can represent it from R, right? At this time, this is the rear, okay? And insert the next value. Next value is 5, right? Okay. Next, again add 1 to the rear. Now rear is this, right? Add next value to the queue, 8. Okay. And next, add 1 to the rear again. And insert the next value. Next value is 7, right? At this time, rear is this, okay? Remember, front not change, but rear is changed. If front is 0 and rear is 3, now our queue is full, right? Our next topic is circular queue, right? There are two problems associated with linear queue, right? They are time consuming. What is time consuming? Linear time to be spent in shifting the elements to the beginning of the queue, right? It is the time consuming. Signaling queue is full, even if the queue is having vacant position, right? Okay.